Hey everybody, we're going to take a look at the Chemistry Unit 5 quiz. Let me go ahead and bring that up on the screen here. Okay, so the Chemistry Unit 5 quiz, we took a look at today. We did a breakout in the classroom and we're able to break out the answer key. So I'm going to go ahead and video that key for you and post the hard copy key on Schoology. So if you're catching this live, hello. I hope you guys are enjoying the rain. If not, this is archived in Schoology as well for you to view later, obviously to rewind or pause. You want to do the problems on the worksheet or the quiz and then play the video back to kind of help you understand it. But if you are getting stuck, this is going to be your resource to being successful. We'll take a look at some more problems on other videos as well. The idea behind Unit 5 is that we're relating how many to how much we have, meaning we're relating the number of particles to the mass of something. And for those of you not in my class, this is looking at converting from grams to moles, moles to grams, and also going from grams to moles to number of particles. So problem number one, we have 2 pennies that have a mass of 6.64 grams, and we want to know how many moles of copper. So we're going to take a look at just doing a quick problem of dimensional analysis, converting from our given grams to the number of moles of copper. So remember, copper is Cu. You're going to need a periodic table as well to do any of these problems. So we're going to start with, since I know I'm converting, I'm going to draw a long line. I'm going to put at the end of the line the units I'm looking for, which is moles of Cu. Then I'm going to start with the given information. 6.64 grams of Cu. Do I know a way to get from grams to moles? Yes. The periodic table has a lot of information on it. One of the things on it is the molar masses of all of the elements. So the molar mass on the periodic table is that larger bottom number. It's not the atomic number that's at the top on our periodic table. It's the larger number for each element. So for copper, if you find copper on your periodic table, you want to make sure that you're recognizing copper is Cu. And then on the periodic table, copper's molar mass is 63.55. So copper is 63.55 grams. And I'm going to write it this way just so you know it's grams per 1 mole. But traditionally, we write it as 63.55 grams per mole. I do know relation between grams and moles. What I want here is I want these units of grams to cancel because that's not the unit I want in the end. I want moles in the end. So in order to get a unit to cancel, I'm going to just bring it down on the diagonal. And I'm going to put grams of Cu here. So my units of grams Cu are going to cancel. I'm going to be left with just units of moles of copper, which is what I'm looking for. I'm going to use this conversion factor here, this molar mass, to convert from grams to moles. The 63.55 is with the gram. So 63.55 is coming down here because that's where my gram unit is. And then 1 mole is going to go up top. I'm left with moles of Cu in the end, which is what I'm looking for. So now I just need to do my math. This line right here tells me to multiply. This line down here tells me to divide. Basically what I'm going to do is make a fraction and reduce the fraction to a decimal. So I'm going to get 6.64 moles of Cu over top of 63.55. I'm going to go ahead and calculate that and should come up with 0.104 moles of Cu. Your calculator probably puts out a bigger answer. I'm rounding to the correct number of sig figs in the problem because there are 3 sig figs up here in my that are the least number of sig figs in my multiplication division problem. So I'm going to have 3 sig figs in my answer. And then just go ahead and box that in. Number 2, a student needs to use 0.485 moles of sodium chloride in an experiment. How many grams should he mass out? Or how many grams should she mass out? The sodium chloride in the problem is a compound, and you want to recognize the compound formula as NaCl. I'm given moles, and I want to go to grams. So I'm going to draw a long line. I'm going to put grams here. And then I'm going to put the 0.485 moles. And again, it's of NaCl. So NaCl, NaCl. Can I get from moles to grams? Sure, I just need the molar mass of sodium chloride. Sometimes we call that the formula mass because it's a compound that has a formula. So I need to put together the molar masses of sodium and chloride. Now, NaCl, there's just one sodium and there is one chlorine. So if I look at the molar mass of sodium on the periodic table, it's 22.99. And for chlorine, it's 35. After a while, you have them all memorized, 35.45. 35.45. Now remember, that's 22.99 grams in 1 mole. That's 35.45 grams in 1 mole of chlorine. Since these are 1 times 1, I'll do this out over here just so you know. I'm multiplying 1 times my molar mass. If these numbers were different, we would multiply them out differently. So draw a line, you're going to add them up, and it should come up with 58.44. 58.44 grams per mole. I want moles of NaCl to cancel, so I'm going to bring that unit down. Moles of NaCl. I am going to get them to cancel. I'm going to be left with just grams. So I set my chart up right. I just need to put in the numbers that correspond to the unit. So the grams is the 58.44, and for moles, it's just 1. There's 1 in 1 mole of NaCl, there's 58.44 grams. Okay, so I'm going to go ahead and multiply across, divide top to bottom. Since there's only a 1 down here, I don't need to divide that. I can just multiply across. So I multiply across and should come up with 28.34 grams. 28.34 grams of NaCl. Check my sig figs. I have 1, 2, 3 sig figs here. So I'm going to go ahead and write this as 28.3 grams of NaCl with the correct number of sig figs. This was one of the problems in our breakout, and I did not have you guys enforce the sig figs just because the lock was a 4 combo lock. All right, I'm going to switch screens here and move to the next set of problems. Okay, so 3 and 4 are here. Let me see if I can get 3 and 4 and not be too high on my screen. Okay, here we go. So there are 17 key nutrients essential for bone health in the human body. Ideal intake of calcium. All right, so calcium, Ca, is 1.25 grams per day. However, most adults only consume about 0.5 grams in their diet. How many atoms of, so here we go, how many atoms of calcium does the average adult need? So how many do we need? Well, I know how many grams I need. I need 1.25 grams every day. But how many atoms? Well, I'm going to be converting. I'm going to draw a long line. In the end, I'm looking for atoms of calcium. I'm given 1.25 grams of calcium. Do I know a relationship between grams and atoms? Not really, not directly. I do know that I can go to moles of calcium pretty quickly. I know the molar mass of calcium. I can go from grams to moles. But that doesn't get me to atoms. But I do know that there are 6.022 atoms in every 1 mole of something. Meaning if I have a mole of something, I have 6.022 of that thing. So if I have 1 mole of calcium, I have 6.022 times 10 to the 23rd atoms of calcium. It's that Avogadro's number. So if I'm looking to go from grams to atoms, I need to go from grams to moles to atoms. You guys have 2, if you're in my class, you have 2 worksheets that have some cool like little images on the top that give you like almost like a diagram of how to go from grams to moles to atoms and back from atoms to moles to grams. So what we're doing is we're converting from grams I want my grams of calcium to cancel, so they're going to come down here. I can't relate grams directly to atoms, but I can relate grams to moles. So moles of calcium. Well, I know 1 mole has, if you look on your periodic table, 1 mole of calcium, there's 40.08 grams. 40.08 grams in 1 mole. So my grams have canceled. Now I'm left with moles of Cu. I don't want moles, I want atoms. So I'm going to bring moles of calcium here. I know in 1 mole there's 6.022. I'm sorry for the second 2. For years it's always been 6.022 for me, but 6.02 times 10 to the 23rd atoms in 1 mole. So now we just got to multiply across. So we're going to put 6.02 times 10 to the 23rd in the calculator. And I always put this number in parentheses. So I put this in my calculator with parentheses around it because I want this to be done first. And then I'm going to multiply this by 1.25. And I mean, technically you're multiplying by 1 as well, but it's the same number. So we're going to multiply across, and then we're going to divide that by the 40.022. When you do that in your calculator, you're going to have a number in scientific notation up top. You're going to divide it by 40.08, and you should come up with 1.88 times 10 to the 22nd. Atoms of calcium. Got the correct number of sig figs because I had 3 sig figs in my problem. All right. And then number 4, suppose that you massed out 3.5 grams of sodium sulfate. So remember I said you want to recognize each one of these. So this is sodium sulfate. So sodium sulfate. How many moles would you have if I had that many grams? So again, I'm going from grams to moles. So I'm going to draw a long line. I'm looking for moles of sodium sulfate, and I'm given 3.50 grams of sodium sulfate, SO4. I want grams of sodium sulfate to cancel, grams of Na2SO4 cancel, that's a 2, it's not looking like a 2. Do I know the relationship? Yes. Again, I know the relationship because I can relate grams to moles using the molar mass of the substance. Because this is a compound, I'm going to need to first calculate that molar mass of that compound. When we do that, we usually say we need to find the formula mass. So let's find the formula mass of sodium sulfate. So there are 2 sodiums. There is 1 sulfur. There are 4 oxygens. So the molar mass of sodium is 2.99. Sulfur is, don't have that one memorized. Sulfur is 32.07. 32.07. And oxygen is 16.00. Multiply across 2 times that is 45.98. 32, oh, that's silly, it's times 1. And then 64. Okay, I'm going to add them all up. Should come out to be 142.05 grams per 1 mole of sodium sulfate. So I'm going to go ahead and put the grams here, 142.05 grams in 1 mole. When you do that arithmetic, 3.5 divided by 142 comes up with a pretty small number. So it comes up to be, what I'm going to do is I'm going to erase this over here so I have some space, okay? So just make sure you're looking at everything. And again, this video will archive in just a minute, so you'll be able to rewind. I'm going to give myself some space because a couple things are going to happen in this answer. So the answer that you get in your calculator is 0.02463, so on and so forth. I was given this number in the problem, and that is a 3 sig fig number. So I want my answer in 3 sig figs. So if I come over here, I'm going to count out 3 sig figs. So I'm going to get 1, 2, 3. This is a leading 0. It's not significant. So I've got 3 sig figs. I look at the next number in line. That means to leave my 6 alone. So it's going to be 0.0246. But we don't want to leave it at 0.0246. I want to put it in scientific notation. So what I'm going to do is I'm going to move the decimal place over 2. 1, 2. And I'm going to get 2.46 times 10, since I moved it over to the right, times 10 to the negative 2. And then I just got to put my units and box in the answer. Okay. 0.02. Oh, that should cancel. Moles of sodium sulfate. Okay. All right, awesome, y'all. Hopefully this helps. I'm going to post the answer key and pop up a couple more videos. Probably not on YouTube Live, on my Screencastify. They should upload into the Unit 5 folder in Schoology. Guys, have a great night. I'll see you tomorrow in class. Don't forget, we are switching rooms. If you're in my class today, this year, you know, we're switching rooms tomorrow to the big lab for the empirical formula. All right, I'll see you guys soon. All right, now time for the awkward ending.